Hello, everyone. Welcome to class. My name is Andrew Knight, and I'll be teaching this semester's course for software testing with Python. You can call me Mr. Knight. I'd like to give a little bit of introduction to myself so we can get to know each other a little bit better, give a quick overview of what we'll be learning in this course, and then talk a little bit about the material for Lesson 1. As I said, my name is Andy. You may also know me as the Automation Panda. I am a software engineer in test, and I currently work in Cary, North Carolina at a company called Precision Lender. I've been in software both as an engineer and as a tester for almost a decade now. I first came to this area, Raleigh, North Carolina area, back in 2007 when I was still in college as an intern for IBM. And since then, I've just been around. I've worked for a lot of companies like NetApp and LexisNexis, and my forte is software testing. I develop testing solutions for companies large and small for whatever testing needs they may have. The Automation Panda bit comes from my blog. You can go check it out at automationpanda.com. You can also follow me on Twitter at automationpanda. So other than that, what can I say about myself? I live here in Cary. I love Nintendo video games. I like to cook when I have time. Spend a lot of time doing things for my blog or for different side projects and all. Personally, I love the Python programming language, and I've been to a number of Python conferences, both to visit as well as to speak. You can find all my talks online at my blog. This will be my first time teaching a college course, which is pretty exciting for me. And so through this course, we'll be learning together, so to speak. Just a few details about the course. Please read everything online through Blackboard. All the information is there. Every week, there will be a new lesson to do. Please, please, please make sure you do everything on time. I'm not going to be accepting late work. Make sure you have your submissions in every Thursday by midnight, and I'll do my best to have them graded the following weekend. The best way to reach out to me will be via my email, which you can find through Blackboard. If you try to contact me, I'll do my best to get a response within a day. Usually I'll be answering my emails in the evening time because I work a 9 to 5 and then I come home for dinner. So the evening, probably between about 7 o'clock and 10 o'clock is when I'll be going through, answering questions, helping you as you need. Also, about these video chats, given that this is an online course, it'll probably be a little bit difficult to connect with me as the instructor, despite all the material that will be posted online. So what I'm hoping to do is, before each lesson, have just a quick video chat together like this. I'll post them out on YouTube, drop them in Blackboard. So that way you can get a little bit more insight into the material. Hopefully I can help explain things to give some direction. So I hope you find them valuable. In this course, we will be covering software testing. And as I said, that's my specialty within the domain of software engineering. I am a software engineer in test. I've done testing, both manual testing, but moreover, primarily automated testing for the vast majority of my career. And in this course, we'll be learning the basics. So by the time that you're done, if you were to enter the industry, you'll be able to know how to do testing, what makes sense, how to see good return on investment, and some basic tooling and best practices with programming with Python. As a prerequisite for this course, I'll expect you to have some basic Python programming experience. Now, you don't have to be an expert. You don't have to know the ins and outs of everything there is to be about Python. Even I don't know that. But you do need to know the basics. So you need to have written some Hello World programs. You need to know about functions, lists, modules, and just some basic object-oriented stuff with classes. If you know that, that'll be good enough for this course, and you'll probably pick up a few more things along the way. So, If you have any questions about the course, about me, about what we're doing, feel free to reach out via email. Let me know. Don't suffer in silence. I'm here for you. So now let's shift gears and let's talk about Lesson 1. Introduction to Software Testing. When we say software testing, what we're referring to is the practice of identifying goodness and badness in software code and features for the purpose of enforcing high-quality standards. Anytime we make something, whether it's software or something else, we want to make sure that it works before we send it out into the world. Otherwise, if it's broken, that makes us look bad and wastes a whole lot of time, right? I'm sure y'all have probably hit software bugs before. I mean, if you use websites like Facebook or Google or Airbnb, I'm sure they just come out of the woodwork all the time, right? Bugs can be anything from something is literally broken, you can't load a page, or you can't hit an OK button, or something takes a really long time to load. All those things are very frustrating. And so software testing is meant to catch these things before your end user does. Now, there are many, many types of software testing. We can talk about functional testing, which is making sure something works or doesn't. We can talk about performance testing, which is measuring how well something works. Is it fast or is it slow? What's the throughput? Things like that, metrics of the system. And we can also talk about experimental testing, meaning if I give you a red button or a blue button, which one's more likely to give a higher conversion rate, right? Kind of survey testing on people, so to speak. In this course, we're going to focus primarily on functional testing, just making sure that the thing we're making works or finding out if it doesn't. There are many, many layers of functional testing, and we'll go through all of them in the future lessons. But just to give you an overview, right? Functional testing means either something works or it doesn't. And usually what we'll do is we'll set up step-by-step test cases. Either they're scripted with a language like Python, or we run them manually. And we execute the test step by step. And by the end of it, we'll find out if it passes or fails. And when we do this for many, many different tests for the different behaviors of our things under test. And at the end of it, we'll come up with a big old report where everything passing is listed and everything failing is listed. There's different layers at which we can test as well. So your bottom layer tests are going to be what we call unit tests. They test the actual code, meaning the actual Python functions or classes and methods that you write. Right? The test case can directly call those outside of the context of your application within a test case. And it can call that code with whatever inputs it needs, gets the outputs out, and does some basic assertions to see, hey, is this what I expected or not? Higher levels of test cases will be what we call feature testing. They can be integration level, they can be end-to-end level. But the idea of a feature test is not that we're testing code, right? Unit tests directly test Python code. A feature test is testing the delivered software product or the delivered software features that you have developed with code, right? Feature testing tests the thing under test more like a user would. So, for example, if you have a web application, a feature level test would be, say, logging in and clicking around and trying some searches, right? Or a feature test could be, hey, you've got a backend system with a bunch of REST APIs with endpoints to hit. Feature testing could be, let's call those REST APIs with different requests, with different inputs and specifications, and see what kinds of responses we get, making sure we're getting 200s when we expect, and maybe some authorized denied 500s when people are where they shouldn't be, right? So unit testing tests code, feature tests test software products. Different layers, and we'll cover all of them in this course. The reason why we have all these different kinds of tests is because we want to make sure we mitigate risks appropriately at each level. It's much easier to catch small problems down at the level of your code, right? If you have a basic string formatting issue or your numbers mathematically aren't adding up right, we can catch that very quickly with a simple unit test that is fast and small and easy, right? However, unit tests don't cover everything because you still need to make sure you have those end-to-end tests that test the flow through your application to see how it would be used for a user, right? Those higher tests, your end-to-end tests, your web UI tests, they're a bit more complicated. You need more code, there's more practice that goes into it, extra concerns, extra setup. So while they're still valuable, you probably want to be pickier about the tests that you would choose to cover. So we have all these layers of tests to make sure that we're safe at every stop of the way, and we're most likely going to have more lower level tests and fewer higher level tests, almost in the shape of a pyramid. Furthermore, with these different kinds of tests, when it comes to delivering software, we can stack them in order in a pipeline of delivery. Right? In most software development shops that are developing products of any size, there is some sort of continuous integration pipeline or delivery pipeline from which the code is committed, built or compiled, unit tested, and then feature tested, right? One step after the other. And so when that software product goes through that pipeline, there are checks at each step of the way to make sure everything was good to go. And testing is a huge, huge part of that. So that's where testing can add value. It's in that delivery pipeline to make sure that every step of the way we're thumbs up and green. And if there are any problems that come out, we can catch it early and right away before it gets shipped, before customers see it, before we get embarrassed and lose I don't know how much money because of damage control and fixes that have to, you don't even want to go there. Catch them early and often. Right. So when it comes to test automation, I want to make it clear that test automation is software development. Right? Those test cases that we write in Python, whether they're unit test level or feature test level, that is software. And so all the best practices you know about writing good code, about good programming, still apply to test automation as they would to a console app or a web application or a back-end system. It's all software. We need to use the best practices we can to engineer these systems. And also, you will need to do programming for test automation because this is software, right? With test automation, we're writing software to test software. It's like an inception moment. It's pretty cool. So you don't need crazy good or crazy high programming skills, right? Test automation overall is pretty straightforward. You're not doing dense algorithms. There's no machine learning here. But you will need to know the basics, like I said. You know, what are functions? How do I use classes? And just use a lot of common sense. And different kinds of tests will need different kinds of concerns to handle. So be mindful of that. For example, with web UI testing, you need to make sure that you're waiting for things to appear on the page before you try to access them. We'll get to that in a later lesson. And with our Python test automation, Python is great for test automation because the language is clear, it's concise, and it's beginner friendly. So you can do a lot without having to code a lot. That's personally why I love Python so much. We'll be using a framework called PyTest. And I think either in this lesson or the next lesson, there will be some activities around setting up PyTest and writing some tests with it. So if you want to look ahead, pytest.org has some tremendous documentation. There's some extra books I can recommend if you really get into it and want to learn deep into what the PyTest framework is. So it's going to be awesome what we got in this course. So yeah, always be honing your programming skills. Apply them well to testing just as you would anything else. And finally, I'll just conclude by saying testing is a really cool thing, right? It is a skill. It's not just a set of practices that we do. It's not just the scripts that we automate to test our stuff, but it's really a skill set, right? You need to be able to think out of the box because with testing, you're trying to guess what is important to cover, right? What do I need to do to make sure that this thing I'm making or this thing someone else is making is going to fly, that it's going to work correctly, and it's not going to crash in a spectacular bouquet of flames or something, right? You need to leverage your critical thinking skills. You need to think outside the box. You need to almost be like an insurance agent doing damage control. What are all the ways that this could explode? And it's not just having 100% coverage, but knowing smartly with the resources of time and manpower that you have, what you should cover and what you choose not to cover just because you don't have time to cover it. So it's a very, very interesting skill. And there are full career paths in this, right? Most people, when they graduate from college with a computer science degree or a software engineering degree, whatever computing degree they have these days. I have computer science. I went to RIT up in Rochester, New York. But whatever degree you have, if it's computer science or anything else, right? Most people come out of college thinking that they're going to be software developers, that they are going to be in a role where they are pumping out code for whatever the main product is. And the dirty little secret is there are more roles in the software industry than just software developer, right? Software testing is a whole set of roles. DevOps is another set of roles. Architecture roles, right? Team lead roles, management roles. There's tons of stuff out there. And software testing is one of those roles that you can pursue, and there's great need for it. Particularly if you are halfway between the development role and the testing role like I am. I am a software engineer in test, also called a software development engineer in test, right? That combines both the testing skill set of thinking outside the box, trying to make sure that you're mitigating risk for whatever products or features that your team is developing, but also the developer role, because you're developing testing and automation solutions, right? You may be making tools. You may be automating scripts in a framework, right? You need those programming skills in order to do that. And so the software engineer in test is a role where you use your development mindset to solve testing problems, right? So that is just one role amongst other roles in software and even amongst other testing roles, because there are testing roles that are purely for manual testing. There are testing roles that are more on the delivery and DevOps side, where you're looking not so much at writing test cases, but rather taking other people's tests and putting them into the delivery pipeline and making sure that everything gets shipped out okay. So keep that in mind as you're taking this course, that this isn't just a side elective that you do. It's really something vitally important to modern software development. So that's all I have to say for this week. I hope you all have a great time in this course with me. Learn a lot. Feel free to ask questions and have at it. Have a good one.